Hello everyone, welcome back to our course on computer vision. I am Kaustav Tripathi, your instructor, and today we are going to talk about bitwise operations. Now, if you are in the maths or in the basic computer, if you have studied about bitwise operations, they are like three basic operations, and there are some operations created with the help of these three basic operations. Those are and, or, not, and operations, not operation, then or operation, and then there are some operations made up from these and or not, and they are like XOR, NOR operations. These are all bitwise operations, and these operations basically works on the Boolean algebra. Basically, works on true or false, 0 or 1. So on these kinds of things, these operations work. And now today we are going to see how these operations can be useful in our image pre-processing. Basically, these operations helps us in masking our images. We mask out the certain sections of the image, and only on the area of interest is visible to us, and rest of the mask out without destroying our image. We just mask it, we don't remove it or destroy it. So that is called masking, and the masking is done with the help of these bitwise operations. So let's, without wasting any further time, let's go on to our spider id and see how we are gonna do it. Okay, so here we are. This is our basic program where we have imported this image Lena 1, and we have also created two black images right now, image 2, image 3. Then what we did is let me zoom it a little bit. Yeah, and then what we did is we created a rectangle and a circle, rectangle on image 2 and circle on image 3, and then we have wrote couples of cv2.imshow methods and wait key destroy all windows that you know. We have imported two libraries, cv2 and numpy. So what we are going to do is these bitwise operations, like we in my previous videos I was using arithmetic operations. These operations works the same way, but only the difference between them is those operations were working on pixels. They were adding the pixels, subtracting the pixels. But here, what will happen is they are working on true or false or 0 or 1. So you might have got a little idea of 0 or 1 concept. 0 means dark, 1 means bright. So it is gonna work on this concept. Means 0 is black, 1 is white, 1 is black, or 0 is white, whatever you choose. Okay. So one thing is clear right now, that to do this bitwise operation, to this masking of images, we need either both black and white images, or one colored image and one black and white image. So that's why I have created these two images as these, and I'm gonna show you right now on these black and white images. To use this bitwise operation, we create this one image 4, and we're gonna do it cv2 dot, if I say bitwise. Now you see here it gives me 4 operations in bitwise: and, not, or, and XOR. These are the 4 operations that we can do in this bitwise operations for the masking. And if I use this bitwise and give it image 2 comma image 3. So now what is happening in this method? Let me print it and show you over there. Okay, so I'm gonna print image 2, and I'm gonna print image 3, and I'm gonna print image 4. Let's put it comment, and if I run this, okay, let me open this image, and this image, and then this. Now you see what we did is we have added image 1 this at frame 1, and this image 2 at frame 2, and it finally becomes this image 3. Oh wait a minute, I pressed some wrong key. Let me run it again. Yep. So what basically happened over here is, now it works an AND operation between these two images, and it finds out the common part between these two images, the common section which is between these two images, that is bright. It will take it as a bright, and that is so. What happens here is, if you put a circle in here, if you create a circle like this, so you'll find this only this much section is common between these two images. If I somehow try to put this image on top of it, you will find that this the circle is created like this, only like this over here, then only this much section in the image is a common part with this square over here that has a white section, right? That's why it has created only that much section in the AND operation and creates a mask of it. Okay, that only this much is visible, rest is everything is black. So now same way if I put OR over here, or let's combine all of these. Okay, let me show you in our different images. Image 5 and I make it OR, and here I put OR with image 6. See what I'm showing. Okay, so now let's run it. Let's see all of these operations. Yeah, now these are our frame 1 and frame 2 over here. Okay, we have already talked about AND, what AND did. Now this is our frame 5. It is our XOR operation. Let's keep it for later. Now this is our OR operation. Now what OR operation does is finds out the white region in this section, the lighter region, and the lighter region in this section, and it adds and it just like merge them up. So all of this section, the circle would be like this somewhat, and it took all of this and created complete white section. So this is like or basically if you see the word or means this or this. If this either this condition or if this condition is true, run the program. If you have in the Python, if you have seen either this condition or this condition, if any of the condition is true, run it. Same way, either this is white or this is white. If any of them is white, make it white. But in the AND, what happened? It says when both of them are if condition 1 and condition 2 are correct, then only run. That means in both of the images, check where the white section is present in both of the places, and then only it gives out that white section of that place. Okay, so now in the XOR, what it does, it is like opposite of AND basically. Okay, in AND, what we have seen, it gives us the the common section. What it does, it removes the common section and gives the rest of the image. So you see here, it removes this common section between them and it gives the rest of the square and the rest of the circle over here. So this is the AND, OR, and XOR operations. You can apply these operations with the help of the images also. I will show you right now. But before that, let's see one more left not operation. cv2 dot bitwise not, and not operation, if you know, not operation requires only one argument. It works on the one argument. Like if I say right now image 2, and if I print it out over here only, okay, you need to see frame 5. Now this is a frame 5, and you see here, this was our image 2 where this square was white, but now what happened is square becomes black, rest of the portion is white. And one more thing, now if we try to add these two images, what do you think is going to happen? Let me show you. Okay, we have this image 4 here. Now I would do I'm gonna apply this uh, image let me copy this part and put it over here, and then I'm gonna write over here image 7 and image 3. Okay, now we will see for image 4. Let's run this. Which frame we have to see? Frame 3. Yeah, frame 3. You see here, this is, we have frame 3 was working for image 3 and image 7. Let's see where we have image 3. Okay, wait, this is getting a little bit confusing. Let's remove all of these things. First, let's comment them out. We don't need image 2 over here. We need image 3, image 7, and image. Okay, we need image 3 and image 7 only, so we're gonna comment out this section also and comment out this section also. Okay, so these two images we need because we are working on image 3 and image 7. Now if I run it, now this was our frame 5 was having image 7, and this was our image of the circle. And you see over here, oh, I have to press some key. But one more thing, we need image 4 also to display, and I missed it out. Now this is our image 7, which we have bitwise. We have used the not operation, and this is our circle image, and this is the operation between these two. So you see, it looks a lot like a anti-XOR, you can say opposite XOR. If you see, the common section in this white and in this white is only this much, right? Rest over here is black and here is white, so it won't count it. The only common section is this. This time it looks like this only. So this is the AND, NOT, and OR operations. Now let's remove all of these. Now we're gonna work this operation with this Lena image, let's say. Okay, so I'm gonna add this Lena image with this rectangle or with the circle, whatever you wanna work with. Let's try it with rectangle first. So I'm gonna create a image 4 is equal to cv2 dot bitwise and I'm gonna put image 1 comma image 2, and in this also you need to make sure that both of these images, wait a minute, both of these images should have same what you say size. I have created this np.0 with the shape of Lena, so I have the same shape, but you need to keep in mind that they both have the same shape always. Okay, so let's comment out other hashes. Okay, we are using image 2 and image 1, so let's print image 1 also. Now if I run this whole program, wait a minute, let me remove, first close this. Yeah, if I run this program, you see this is our frame 1, this is frame 2, and we did the masking in this. Now you can clearly see what is masking this. We can only see this much of the image, means this much of our area of interest section only we can see, and rest is all masked out with this black color. Okay, this is called masking, and okay, wait a minute, this is called masking, and we can apply this concept in much more if when we are gonna do much in photo editing in the world, or when we are gonna go deep in this image processing, then we will be having a lot of requirement of this bitwise operations, this masking concept. So this is a masking. Same thing we can apply for uh, wait a minute, same thing we can apply it with a circle. If we put a image 3 over here, and wait, and if I run this, now you see the circle section, wherever the circle is over here, only that much part will be visible, rest of it becomes black. So these are bitwise operations in OpenCV. So keep trying it, try to create a mask, try to just figure out the face of someone, or create some squares, or work with the OpenCV logo. There are lots of things to work with in this operation. Try to create masks of other things. Okay, so keep practicing it, see you in the next video.